Hello one and all, it's time to start the new chapter through the video. The name of the chapter is Permutations and Combinations. So the permutations and combinations starts from factorial. There is a factorial term. So just see, factorial is symbolized by this or this. And the meaning of factorial 1, starting from factorial 1, this is also called factorial 1, this is also called factorial 1. This is simply 1. Factorial 2, 2 multiply 1, 2. Factorial 3 starting from 3, 3 to 1, 6. Factorial 4 start from 4, 3 to 1. So the factorial of any number starts from that number. After that, at a difference of 1, it will go ahead. And the last term will be 1. So these are the factorials. Now some tips to do the problems. Factorial 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This is factorial 10. If 10 is taken outside, the remaining is called factorial 9. This is called factorial 9. So 10 factorial 9. Similarly, if 10 and 9 both are taken common, 10, 9 taken common, then we are left with factorial 8. So this is 10 into 9 factorial 8. So this type of habit will be helpful to you to do the further problems. Factorial 10. If 10, 9, 8 are taken outside, factorial 7 is left. This is factorial 7 is left. So you can take out the numbers, conjugative numbers. But remember that the conjugative numbers must be taken, starting from the highest. Now you have to simplify factorial 10 by factorial 7. So 10, 9, 8 taken outside, factorial 7 is left. So this is cancelled with this, and 9, 7 7, 9, 8 72. This is the answer. Suppose you have to do clearly without using this concept, then you can write down this. Factorial 10 means 10 to 1, factorial 7 means 7 to 1. So this is cancelled, and again we are getting 9 at 72. 720 answer. But this is the best rule to do the problem, remember it. Now the further problems, just see. Suppose you have to solve the equation like this. Solve factorial n by factorial n minus 2 is equal to 12. Solve this equation, find the value of n. Now factorial n is bigger than factorial n minus 2. So this factorial n can be written as n minus 1, n minus 2, and so on 3 to 1. Like factorial 10 can be written as 10 into 9 into 7 into 8, 3 to 1. Likewise, this can be written as a difference of 1. We are moving towards 1. So you have to cancel n minus 2. So if n into n minus 1 taken common, we are left with n minus 2. As I have already suggested you that if 10 and 9 are taken common, 10 into 9, the remaining is factorial 8 is left, 8, 7, so factorial 8. Likewise, this can be written, so this means n into n minus 1 divided by factorial n minus 2, and this n into n minus 1, after that factorial n minus 2 is left. So this is 12, so this cancelled by this. Now we are getting n into n minus 1 which is equal to 12. You can multiply it and you can do by quadratic formula or mid-term splitting. But remember it that both are conjugative. This is big and this is a small. So both are conjugative. So the factor of 12, 4 multiply 3, 4 and 3 are conjugative, and this is big and this is a small. This is the fastest way to do the problems. Now this implies n into n minus 1 is equal to 4 into 3. So by comparison, this is called comparison. By comparison, n is equal to 4 and n minus 1 is equal to 3. So this gives n4, this is already giving n4, and hence n is equal to 4 answer. So in this way we can do the problems of factorials, solving equations. Taking one more example. Now one more thing, student, the proof will be given later on. Factorial 0 is 1. Remember. The proof of the factorial 0 is equal to 1. It is surprised. Factorial 1 is also 1 and factorial 0 is also 1. But factorial negative not defined, not available. So the factorial negative is not possible. Now come to another problem. Simplify, or better to solve factorial n upon factorial n minus 3, 720. Suppose it has to be solved, finding the value of n. Now you know that 10 in factorial 10 is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So if 10, 9, 8 is taken outside, we are left with factorial 7. Likewise, factorial n is equal to n into n minus 1 into n minus 2 into n minus 3, and lastly 3, 2, 1. The last term will be 3, 2, 1. You may not write the middle terms, dot, 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 you can write. If 3 numbers are taken, if n is taken outside, n minus 1 taken outside, n minus 2 taken outside, n minus 3 is left for other, from this to this. This is called factorial n minus 3, starting from 7, 6. Starting from 7, we write factorial 7. So starting from n minus 3, we write factorial n minus 3. Now just do this n. This is 720. This is cancelled. And after that, we are getting 3 consecutive terms. These are the 3 consecutive terms, big, small, more, small. 720. So break 720 in 3 consecutive terms. Now just see how 720 is such. 3 consecutive terms. 3, 2, 1, not possible. 720 again. 4, 3, 2, 1. 4, 3, 2, not possible. These are the 3 consecutive terms. 720. 5, 4, 3, not possible. And similarly, you can go ahead. 720 is equal to 10 into 9 into 8. 9 8 is 72 into 10, 720. So this is the consecutive factors, 10 into 9 into 8. Now by comparison, we can find the value of n. So n is equal to 10. Remember that big, small, small, big, small, small. The order should be maintained. So this is another n minus 1 is 9, another n minus 2 is 8. So from all the 3 parts, we are getting n is equal to 10, n is equal to 10, this is already n is equal to 10. So finally, n is equal to 10 is the answer. So in this way, we can do the problems. Now moving towards the further problems of the book, convert into factorial. This is second number question of your book. Convert into factorial. Convert into factorial. The problem is 10 into 9 into 8 into 7. So you have to convert it to factorial. So let us start. This is 10 into 9 into 8 into 7. Now continue it up to 1. So 6 into 5 into 4 into 3 into 2 into 1. After that, the same thing will be divided. 6, 5, 2, 1. Now this is continued, starting from 10 ending to 1. So this is called factorial 10. And starting from 6 and ending to 1, this is called factorial 6. So our n is over. The given expression is expressed in terms of factorials. Again, next problem of the same second number 2. Express to factorial. This is 12, 10, 8, 6, 4, 2. It has to be converted to factorial. So remember, students, so 2 is a factor of all. 2 is a factor of all. So take 2 factors, and 2 factors, and again 2 factors. These are the factors. The factors are being taken 6 times. So this is 2 to the power 6. When 2 is taken from 12, it becomes 6. When 2 is taken from 10, it becomes 5. When 2 is taken, it becomes 4. When 2 is taken, it becomes 3. And when 2 is taken, it becomes 2. And finally 1. 2 is taken outside. Now this is 2 to the power 6 into. Starting from 6 ending to 1 is called factorial 6. So our problem is done. Now taking another problem, solving, you know, one more solving is being taken, n plus 1 factorial. Solve. N plus 1 factorial is equal to 12 factorial n minus 1. Solve this. In order to solve this, remember that n plus 1 factorial is written as n plus 1. After that 1 less n, then n minus 1. Dot 3 to 1, it will end to 1. So starting from n plus 1, after that एक कम हो जाएगा, फिर एक और कम हो जाएगा. You need n minus 1. So this can be written as n plus 1 into n. After that this is n minus 1 factorial. This is separated. So use this factorial n plus 1. This can be written as n into n minus n plus 1. N factorial n minus 1, 12 factorial n minus 1. So this is cancelled. Now you are left with 2 consecutive terms, n plus 1 into n, and earlier I have told you that the 12 has got 4 into 3. So these are the 2 consecutive terms. On comparison, we get the value of n plus 1 4, and n is equal to 3. So this gives n 3, n 3. So this is the final answer. In this way, we can solve the problems of factorials. Now taking another problems, prove that n into n minus 1, third number. Prove that n into n minus 1 into n minus 2, dot. Lastly, n minus r plus 1 is equal to, this is equal to factorial n by n minus r. Better to start from RHS, or you can start from LHS. Let us see from LHS, n into n minus 1, dot, n minus r plus 1. After that students, एक जब घट जाएगा, एक और घटेगा तो n minus r हो जाएगा, फिर n minus r minus 1, एक एक घटते जाएगा, लास्ट में 3 to 1. ये एक्स्ट्रा, दिस इज एक्स्ट्रा written by you, continued up to 1, and the same thing will be in denominator. Now this is starting from n and ending to 1, so this is called factorial n upon, this is starting from n minus r ending to 1, so this is called n minus r. This is n minus r, so RHS is proved. Next problem. Factorial 2n, very good problem. Second 2. Factorial 2n is equal to 2 to the power n. Very interesting problem. 2 to the power n. Factorial n into 1, 3, 5. Lastly 2n minus 1. This is very interesting problem. Starting from LHS, factorial 2n. This is 2n. Number of terms will be 2n. 2n minus 1, 2n minus 2, and dot. This is 6, 5, 4, 3, 2, 1. Ending to 1 starting from 2n. Now this common making two groups better. So in first group 2n minus 2 dot 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 6, 4, 2. And in the second group these are the left 5, 3, 1. So 2n minus 1 dot 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 5, 3, 1. So this is over. This has been proved. This part has been proved. Now see 2 common, 2 again common, again 2 common, again 2 common, again 2 common. So how many times 2s are taken common? N times. N times you are taking 2 common. So this is 2 to the power n. Now when 2 is taken common, it will be n. When 2 is taken common from this also, it will be n minus 1. When 2 is taken common, 3, 2, 1. And this is already 2n minus 1 dot dot 5, 3, 1. Now just see, this is 2 to the power n, and we know that starting from n and ending to 1 regularly, this is called factorial n. And this is already 2n minus 1 dot 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 5, 3, 1. So this is proved. This is RHS. So how successfully the problems are being answered? Similarly, we can take 6 number 6. Prove that factorial 33 is divisible by 2 to the power 15 or 2 to the power 16. So let us see factorial 33. This is 33 into 32 into 31, 30, so on, 6, 5, 4, 3, 2, 1. Again, you separate the even terms, even number. Even numbers are being separated. So this is 32, 30, dot dot 60, 6, 4, 2. And after that, this is 33, 31, 5, 3, 1. So now 2 taking common, 2 common, 2 common, 2 common, 2 common, 2 common. 2 common from everywhere. Then now see how many times 2 can be taken common. 16 times. There are 33 terms total. In this, there are 16 terms, and this 17 terms. So when 16 and 17 added, we get 33. Now this is 2 to the power 16. 16 2s can be taken common. So we are left with 16, 15, and this is lastly 3, 2, 1 into 33 into 31. No factorial can be assigned for this because there is a gap of 2. In factorial there is a gap of 1 everywhere. So this is 2 to the power 16 factorial 16. This is 16 and starting from 16 and ending to 1. And this is already 33 into 31 dot 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 5, 3, 1. Now this is clearly divisible by 2 to the power 16 or 2 to the power 15, whatever you like, 2 to the power 14 also, and in this way the problem is done. Thank you very much, student. The remaining problem will be discussed later on. Thank you.